Okay, next up, we have Vivian Shi, who joins us from the Biomedical Engineering Department. Vivian will be presenting a talk titled Building a Better Bone Graft. Welcome to the stage.
Lindsey Vonn's crash at the Olympics shattered her leg. We've all heard these stories. Athletes break bones and they bounce right back. But for 5% of patients, the bone may not heal completely. The result is chronic pain, repeat surgeries, and sometimes permanent disability. When bone is lost due to trauma, tumors, and infection, sometimes the body can't rebuild on its own. So how do we regrow bone? Currently, the most common solution is to take a bone graft from the patient's hip. But a second surgery risks infection, and nobody wants long-lasting hip pain. Instead, researchers have developed synthetic grafts made out of materials that can support bone healing. My lab studies these synthetic grafts, or scaffolds. When you think of the word scaffold, you might think of the sidewalk scaffolding of New York City with the crisscrossing network of metal support beams. A scaffold for bone acts similarly, providing a physical framework on which bone cells can grow. This is what current clinically approved synthetic grafts do. But a scaffold can do so much more. A scaffold can induce bone formation. By engineering the chemistry and geometry, we can tailor a scaffold to recruit stem cells and direct them to become bone-forming cells. It's the difference between simply existing as scaffolding versus calling in workers to fix the building. I focus on one particular scaffold material, hydroxyapatite, which is the mineral that your bones form from the calcium that you eat. I design and 3D print hydroxyapatite scaffolds to study how to better grow bone. To test my scaffolds, I implant them in mice in an area that doesn't naturally grow bone, in their backs. With this method, we've identified a hydroxyapatite material that can grow bone even without the help of the mouse's native bone cells. Then, when I implant the scaffold into a mouse femur injury, we can see the bone heal itself. In the end, I want to develop a safe bone-forming scaffold that can be tailored for any patient. With our knowledge of the material and 3D printing, we can imagine in the future printing a scaffold that can perfectly fit any injury site, anywhere in the body. This work could redefine our expectations of synthetic grafts and ultimately improve outcomes for all of us who simply want to get back out there and go for gold. Thank you.